A very warm good morning to one and all present over air class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss the theory related to vectors theory. So class, in previous lecture I have also discussed some theory related to vector algebra. So see, now in previous lecture I have completed the types of vectors. So class, now in today lecture I will discuss the position vector. The position vector. Now you know position vector of a points or of a given points. Position vector of a given point. Now see, let us consider capital P having coordinates x, y, z be represent in 3D, three-dimensional space as shown in figure, or represent in x, y, z, or we can say three-dimensional. So three-dimensional space see, this is three-dimensional space, x-axis, z-axis, and this is y-axis, positive x, positive z, positive y. Now this is the origin with respect to three-dimensional space, that is coordinate is 0, 0, 0, and we have considered any points P represent in xyz space plane. Now you will see we have considered any points P having coordinates x, y, z, and the position vector of a point P with respect to origin O. Then the position vector of point P with respect to origin O means 0, 0, 0, that is represented by OP vector, such that we can write OP is equal to, consider R. OP is equal to vector R. where O is the initial point of vector OP and P is the terminal point of vector OP. Where O is initial point and P is terminal point of vector OP. So join OP. This is point P and this is OP is equal to R. Now you can see OP is equal to R, such that OP we can write OP is equal to x minus 0 I with unit vector plus y minus 0 j with unit vector plus z minus 0, this is 0, k with unit vector. And now OP is equal to xi plus yj, this is j plus zk. Now see, now mod of OP, this is the result OP, that is mod of OP, and mod of OP means mod of OP is equal to mod of R is equal to root over x square plus y square plus z square. Now see, so this is the position vector. Here I am writing and defined by, and defined by now this one is completed. Now I will come to the next heading. Next heading is triangle law of vector addition. Triangle law of vector addition. Now see, triangle law of vector addition. Now see, let capital OAB, we are going to consider any triangle. Capital OAB be a triangle representing three-dimensional space where O is the origin. Suppose that we have considered, that is O coordinate is 0, 0, 0. Now you will see this is the point O having coordinate 0, 0, 0, and AB, suppose this is AB, this is O. Now we can suppose this is x-axis, this is z-axis, and this is y-axis, y positive axis. Now see, and let OA vector, we are considering vector A, and OB vector, that is a small b vector, and vector AB, what we can write? Vector AB represented A and B vector. Now from figure, according to triangle law, what we can write? We can write, now according to triangle law, OA vector plus AB vector will be equal to OA plus AB. OA plus AB will be equal to OB vector. Now see, now this result we can consider This is AB. Suppose AB is equal to vector B. Now we can write OA vector is small a vector and this is small b vector is equal to OB vector. So this is the triangle law of addition. Now you can see. Now I will come to the next question. The next theory is not question. Now see. Now next topic is section formula. Section formula. Let us consider capital A and capital B be any 2 points represent in 3D space and O be the origin such that O coordinate is 0, 0, 0. Now see. Capital A, capital B. Now let OA vector is equal to small a vector and OB vector is small b vector. Now R be any point and C be any point such that vector OC is equal to R, which divides this is C, which divides the line segment joining 2 points A and B into m is to n ratio. Or we can say or vector R divides line joining vector A and B into m is to n ratio. Suppose this is vector R, this is vector A, and this is vector B. Now the coordinates of R, what we can write? M is to 1 ratio internally what we can write? Internally we can write means R coordinates we can suppose, or vector R that is m into A vector plus n into B vector whole upon m plus n. And now externally vector R will be equal to m times vector A minus n times vector B whole upon m minus n. And now in case of midpoint, when C is the midpoint, when C is midpoint, means then vector R, or R is the midpoint, or C is the midpoint, not R, C is the midpoint, then vector R is equal to vector A plus vector B by 2. So these are the three formula, you have to all learn this. Now this is x-axis, this is y-axis, and this is the z-axis. This is the z-axis. Now this is origin. Okay. Now in case you will see we have completed section formula internally, externally, or midpoint. See, this is internally, this is externally, and this is third point, midpoint formula. See, in straight line you will also see you have already discussed section formula, but in terms of Cartesian coordinate system. And in vector coordinate system you will see these coordinates, or this format will be m times A plus n times B whole upon m plus n, and m minus n, m times A minus n times B is equal to or upon m minus n, and vector R in terms of midpoint, or when C is the midpoint, and when vector R is the midpoint, of joining two vectors A and B, then in case vector R is equal to A vector plus B vector. Now you can see. Now this topic is totally completed. You can see. Here you will see vector R, and this is point C, B and A. Now any doubts, you can clear it without any hesitation.